Assalamu alaikum dear students, and hello everyone. Welcome back to Learn Daily Physics, and today you can see that we are going to start our next lecture, which is I think probably lecture number 10 of plasma physics. So this is the case for the finite E. So let's move toward our book. So previously we have started our lecture number 2. This is F.Chen's. You can see this is F.Chen book, F.Chen Introduction to Plasma Physics and Controlled Fission, and we have started its chapter number 2. We have done these equations and we made our graph. This one you can see. I'm telling you just because we are going to use these equations in today's topic, so you have to understand this. Okay, so this was the graph for E was equal to 0. Okay, when E was equal to 0, as you look in your previous topic, here F is equals to Q into E plus V cross B, and E is equal to 0. For the first case, E was equal to 0. But today we are going to find out a relation for a finite E. You can see here that there is a finite E. E is not equal to 0. We have some value of E, and E lie in the plane X and Z. When E is lying in the plane X and Z, the y component of E is 0. You can see here. Then we have X and Z component here, y component is 0, and we will calculate our all equations, and at the end we will see that there will be a little bit difference in this graph. This is the graph when E was equal to 0, and we will see that what will be the motion of plasma when it will be placed in a magnetic field along Z axis and an electric field along X and Z axis. Okay, so this is the plasma, and plasma shows gyration when it is placed in a magnetic field. Now we will see that when there is a magnetic field but there is also an electric field, what happens to the plasma. Okay, so let's move on toward our lecture, and we will see what will be the change in this graph. So first thing in first was E equal to 0, but in today's lecture E is not equal to 0. Okay, so we have some value of this E, and B is not equal to 0. E equals to Ex of I plus Ez of K, and you can see that Lorentz force, in the Lorentz force, F is equals to Q into E plus V cross B. Okay, this is E, and putting the value of E and V cross B, how to cross, we know that how to calculate a cross product. To calculate a cross product, we take its determinant, and we have took its determinant is like will be like this, and it will be taken that for I component Vy will be multiplied with Vz minus 0 into Vz, and you know how to take a determinant, and this determinant will be equal to this term. Okay, this is V cross B equals to this term. Okay, so putting the value of this V cross B from this equation here, and this value of this E here, and this multiplying this Q inside this E, so it will be Q into EXI plus Q into EZK plus this is VYB of Z, Q into VYB of Z minus Q into VXB of Z. So then we know that force, we have a force, and we know from Newton's law F is equals to ma. Force is equals to mass into acceleration, and acceleration can be written as dv by dt. Acceleration is the time derivative of velocity, and this time derivative of velocity can be written as f can be written as m into v dot. So dividing this m, we can write this f is equals to mv x dot component, dividing it, splitting it into the components. We have resolved it into components and x, y and z component, mv of x, mv of y and v of z with respect to their respective unit vectors. And the right side we will write these equation like this, putting these values here, and it will be the equation like this. Now we will divide this m here and a little bit rearranging that we will take this p in the first term and this in the second term. We will see that this term q over m bz is equals to minus omega minus plus minus omega c. This is equals to cyclotron frequency. This term here equals to cyclotron frequency. And in my previous lecture I've told you, if you have seen my previous lecture, lecture number 9, in that lecture you can see from animation that how this cyclotron is formed, this graph, how this graph is formed. You can see in previous lecture. I hope you've already seen it. If you have already seen that lecture, it is good for you. But if you don't yet seen that lecture, you better go there. You have to go to my playlist. I will put the link in the description. So you have to go for the lecture number 9 and the previous lectures also to understand this lecture clearly, because when I'm going to use my previous knowledge, the knowledge from my previous lectures in this lecture, it will cause a trouble for you, then you can understand. So if you haven't seen my previous lecture, you better go there and watch them also. So from that, m is divided here, and I've compared the coefficient of ith coefficient, jth coefficient and k coefficient. Okay, k unit vectors, I unit vector, they are all compared from left to right, and v of x is equals to, we have this I component here, I unit vector, and this one here and this one here. So I write this, I wrote this here. So second one, j unit vector, I have this term, only this term here. Okay, so for the k unit vector vz, I've seen that I have only this term here. So if you see in your previous lecture, for the when e was equal to 0, we don't have any acceleration along z axis. We don't have any acceleration. This is vz dot, which means dv by dt. Okay, vz dot means, if you see what vz dot is, vz dot equals to d vz by dt, and you can say that this is acceleration along z-axis. So when e was equal to 0, this is the case when e is equal to 0, there was no acceleration along z-axis. Okay, there was no acceleration along z-axis. We don't have any v dot of z was equal to 0 here. But when electric field is applied, now we have some acceleration in v of z. Okay, this is the first difference between when e was equal to 0 and when e is not equal to 0. Okay, so you understand that this is the first reason that when we apply electric field, it will accelerate toward the z-axis. Okay, so moving on, writing this as an omega c, it will minus plus omega c v of x, and this one also, when we multiply b of z here and divide this b of z here, q over m b of z will be equal to minus plus minus omega c, and the dividing b of z will be equal to e z over b of z. I wrote this like so, it will be equal to q over m b of z multiplied e z over b of z. So this term equals to minus plus minus omega c, and this is e z over b z. So this is my equation number third. This is the third equation, equation number 3. So these equations here are the coupled equation. Okay, now the question will be arising in your mind, what is a couple equation? We have couple equation in electromagnetism when you are studying. There were Maxwell equations in electromagnetism, four equations, Maxwell equation, and you can see that, for example, I show you one, that curl of E, differential form of Faraday's law, curl of E is equals to minus partial B by partial T. This is a Maxwell equation. This is a Maxwell equation. So this is a couple equation. I can say this is a couple equation. How this is a couple equation? The question will be arising in your mind. So a couple equation is relating. You know that couple means there is a pair of something. Okay. Couple means that a couple means there is a husband and there is a wife. Okay. Means there is a pair. We have two things. So this is a couple equation that in this we have two things. In the left we have electric field, okay, but in the right we have magnetic field, okay. In the left we have electric field and in the right we have magnetic field. We decoupled them in our electromagnetism course of electromagnetism. You can see also in that playlist. It's not our concern here, but these are the couple equations. Now moving this way, how these equations are couple equation? You can see that there is a Vx of dot. Let's move toward this equation. There is Vy dot and here there is V of x and V of z. Y component here, z and x component here. Okay. We have one component on left side and another components on right side, so we have to move toward a same component. Okay, and we say that there is a y component here and an x component here. Okay, so we want them both to be in one component, either on in y component or in x component. Okay, so let's, for that we decouple these equation. Okay, so now we are going to decouple them. So for the decoupling, here it is. So for the decoupling, the thing what we will do is we will take the time derivative of this equation. You can see this equation number 2. We have a y here and x here. We want a y here, also a y here. Okay. So what we will do that, we will say that the velocity component should be in y. So we will take a time derivative. When we'll take the time derivative, there will be the Vy double dot here, Vy double dot equals to minus q over m b of z, this term, minus q over m b of z Vx of dot. Okay, this is after the time derivative of this equation number 2. Now from equation 1, from this equation we are going to put the value of this Vx dot, and this equation is equal to this term, and we put this value here from equation 1. It will be equal to this term. We multiply this, we take this as a omega c. This value equals to omega c minus plus, because there is a minus, so the signs with the omega c will be inverted and it will be the minus plus omega c, and the inside of it we are writing in this step, we are going to write this as it is. In the next step we will form this omega c just like before. We form this one as an omega c. This is equals to omega c. You can see Ex over Bz plus minus omega Cv of y. Okay, now in the next step what we are going to do, in the next step we are going to taking the common of this omega c. When we will take the common of this omega c, we are having this negative sign, only negative sign. Why we are having this negative sign here? There is a minus plus here, plus minus here, plus minus here, two signs are here, but in this case we are having this negative, only a negative sign. Why? There is a reason behind it. The reason is, when you are going to multiply this minus plus with this plus minus or with this plus minus, the answer will always be a minus, negative sign. The answer will also be a negative sign. How the answer will also be a negative sign? Minus plus minus, minus plus minus, this plus minus minus, or this plus minus minus. So our answer will always be a minus, so we are going to only write this minus here. So we write this as, and we forget about this equation now. So there is a term inside the bracket is e of x b of z plus v of y. For our simplicity to calculate this, we will assume this term as u. We say that this is equals to u is equals to e of x over b of c plus v of y. There is no omega c here, okay? So it was written by the mistake. So we are going to write u instead of this. So our equation will be v double dot of y equals to minus omega c square u, equation number 5. So now taking the derivative of this u, when we take the time derivative of this u, it equals to, this term equals to 0, it goes to 0 because there is no time dependence on this equation, and this vy gets a dot on it, okay? When we take the second derivative, here we get double dot, vy double dot. From this we can say that u double dot equals to v double dot of y, and v double dot of y equals to this term. Oh, I was saying all that and you can see that, so I have to say this again. So for that, now for that we are going to consider this equation as u, okay? So letting this inside term as u, our equation will be this u is equals to e of x bz plus v of y, this term equals to u, and our equation, this equation will be vy double dot equals to minus omega c square, and now this term equals to u, and u is equals to this whole factor. When we take the time derivative of this u, what happens? When we take the time derivative of this u, this first factor goes to 0 because there is no time dependence on this. This is time independent, it will be 0. Our second term will get a dot, okay? When we will take the second derivative of this equation, we will get a double dot, okay? From this equation we can say that u double dot is equals to v y double dot, okay? And this vy double dot equals to minus omega c square u. So this u double dot is equal to, by comparing this equation and equation 5, this small equation 5, we can say that u double dot is equals to minus omega c square u, and we are going to write this as equation number 6. We are doing all this thing to calculate v of y. The thing what we have to do is we have to calculate v of y. What is v of y? What will be the change of v of y? We have calculated the acceleration along z axis. Now we have to calculate v of y as we did in our previous case. So this equation is a differential equation, second order differential equation this is. So we can find a solution for our second, general solution we can find for our second order differential equation. How we find that? We make a characteristic equation, then we find it's an auxiliary equation, and from that auxiliary equation we put them into the conditions and we find our solution. So just like that, we are going to write its characteristic equation. For the characteristic equation, d square is equals to minus omega c square u, and d will be equals to plus minus iota omega c. This is our characteristic equation. So now this is characteristic equation, and the solution of this characteristic equation will be a auxiliary equation, and this auxiliary equation is equals to u equals to plus minus alpha e power iota omega c t. This will be the solution for this equation. How we find this solution? This is another course. There is a whole course about it named as ordinary differential equation. You have already studied this, because this is a compulsory course of ordinary differential equation, and in ordinary differential equation we do all these things. Okay, so you know this, that u is equals to plus minus alpha e iota omega c t, and now putting the value of this u here, and by putting this value here from this equation, u equals to this term here, we are going to calculate v of y. This is our concluding equation for today's lecture, that v of y equals to plus minus iota alpha e iota omega ct minus e of x over b z. Okay, if you might have recalled your previous equation, which is quite similar to this equation. Let me see you that. Look in our previous lecture, here it is. This is the equation from the previous lecture. Vy is equals to plus minus iota alpha e power this term, and as you see, this equation 6, and this is also, I think, equation number 6. So comparing the equation number 6 from my previous lecture and from today's lecture, this is the equation from my previous lecture, and this is the recent equation we have derived. Okay, so there is a similarity between this equation. Plus minus iota alpha, this first term here is same. Okay, so this was the equation when there was no electric field. Okay, E was equal to 0. This is the equation. But when E was not equal to 0, this is the equation. Okay, so there is a difference between these equations. Then when E was equal to 0, we have this equation, and when E was not equal to 0, we have this equation. And how to understand this? Let's say that when E was equal to 0, we have something 5. V of y was equal to 5. Let's say it was equal to 5. But when E was not equal to 0, V of y equals to 3. It means that it is subtracted by a factor, and that subtracting factor is equals to E of x over B of z. So E of x, from that we can say that E of x over B of z is equals to 2. And because of that, as this V of y is changing now, so it will impact our graph, and our graph will move a little bit higher. Okay, now this graph won't be on the axis on z. Okay, this velocity is changed now, and because of this change in the velocity, now this graph will be changed. And now let's see on our book that how this graph is formed. This graph is now formed like this. The gyration, you can see that the plasma performing the gyration is above the axis. Why this is above the axis? Because now we have a little bit change in V of y. V of y is changed from this to this. Okay, so now we have seen that how we have done this transformation from this to this. Okay, so this was the thing, the actual orbit of gyration particle in space. This is the actual part. When E was equal to 0, this was the gyration, and when E is not equal to 0, this is the gyration. Now you understand how this gyration is changed. I hope you understand, and if you understand, and you understand everything, it's good for today. Our lecture is enough now. So in our next lecture we are going to find out this drift velocity, that what is the change in the velocity and what is the drift velocity, and how this drift velocity is equals to E cross B over B square. Okay, so till then, assalamu alaikum. If you've liked my lecture, so you better subscribe to my channel, and you give me a thumbs up and comment if you have any problem with that. So I'm trying my best to convey everything that I have. So you have to try your best to convey me everything what you have. You can give me a thumbs up and a like for my video, and you can also give me a comment if you like this. So assalamu alaikum, and wait for the next lecture. Until then, assalamu alaikum again.